Okay, so this is 17.4, number 5. That's supposed to be a 5. Okay, which says, what the hell am I supposed to do with this thing? So they told me v is xj, and x of t is a, and y of t is at plus b.
We're finding the vector field on the flow.
Okay, so there's a vector field here, right? So to rephrase this in kind of the way I like to think about things, I would think, here's my vector field, right? It's given by what vector?
0, 0, x.
0 and x. You guys all with that? Right, because there's no I component. So really you might think this is plus 0I, right? Okay, so there's your vector field, right? And then what's this whole business that they give you? That's like a flow line, right?
Mm-hmm.
So I'm thinking about that as like, that's an R of t, right? And that R of t is given by?
A comma at plus b.
Perfect. A comma at plus b. Okay, dokes? Yes? Okay. So, what did they want me to do? They want me to sketch this thing, right?
Sketch the vector field and the flow.
Okay, so first things first, let's sketch the vector field. What's the vector field look like?
On the right, it kind of goes up, and on the left, it kind of goes down, equal to how far away it is from the origin.
Okay, right, so along the x is 0 line, right, that's the y-axis, you just have the 0 vector, right? And then when you go any bit right of that, this thing points up by the amount you went right. So like out here at 1, it's pointing up by 1 unit. And then if you go out to 2, it's pointing up at 2 units. And I'm just kind of drawing these any old place. These vectors are supposed to be twice as long as those ones. You guys see that? Okay, and then over here on the left-hand side, it goes down. Oops. Oh, a little short. It's cool, this picture, more or less. So this is like shear flow, right? Okay. And then here I've got an R of t, right? So that's supposed to be at A. Do I have a value for A?
Just some constant, apparently.
Yeah, it's just some constant, right? So let me just pick a couple options. So one flow line for that could look like, if you go over right someplace, like here. So that's me pegging an A value, right? So I've said A is whatever this distance is. What changes as you progress time
It goes up.
in your flow line?
It goes up in the y direction.
Right, you get, do you know where you start? Do you know what happens when t is 0?
You're at a position.
It's at A comma B, right?
Yep.
Okay, so maybe I start up here. This is me thinking t is 0, so this is the point A comma B. Right? And then from there, as time progresses, I'm going to go up in the y direction. Why do I know that it's up?
A is the same as.
Yeah, because A is the slope on the y line, right? And that's, I went right, so that slope is positive. So it's going to go up. What happens as time is negative? Yeah, it's going to go down, right? So this whole thing looks like this, progressed that way. It's cool with this?
Mm-hmm.
So this is like for negative times, for time is 0, and for positive times.
Mm-hmm.
Cool, cool? All right. What if that thing's over here instead?
It should go down.
So like maybe up here. If this is t is 0, right? That's the point A comma B. that thing is, instead of going up, going to go
Down.
down.
The answer key shows that it's going, that the flow is going up on the left side.
Oh.
Yeah. This is where we got the confusion, because we got the same thing you got, but the answer key says it's going up on the left side, and we don't know why.
They just one took time over.
Hmm?
They just screwed up.
They just messed up.
Yeah.
Okay.
They have a lot
Okay.
of college kids just checking books. That's what Muriel always said, so like.
Yep.
this
Yeah,
does happen.
the answer keys, like usually the exercises are thought up by somebody who has like a plan and a goal. That might be the author, probably not. Usually the author's grad student. But the answers in the back of the book are usually done by the first class that they teach it to. So that's you guys, like. I mean, this is what, the second or third edition of this textbook? Sixth edition? You would think they would get all the errors out of the back by now, but probably this problem went in with the fifth edition, and it's just a little dork. What was this bit about? Because the instructions didn't stop with sketch this thing, right? They had and also.
Let's see. Then find the system of differential equations associated with the vector field and check that the flow satisfies the system.
Yeah, so what's a flow line supposed to satisfy? You guys remember that? Okay, so again,
Path of the vector field at a given point.
so a flow line's supposed to satisfy,
That r derivative of t equals f of rt.
perfect. Right, it's supposed to satisfy the tangent line to your curve, right? The tangent line to your flow should be the vector field evaluated at the spot you're at, right? This flow should be pushing you along your tangent lines. Otherwise, it's pushing you some other direction, and that's going to be off of your curve, hence that won't be a flow line. You guys all see that? Okay, so, oops, I lost a parenthesis. So, what's f of r of t?
Is that the,
That'd
Oh.
be a zero.
it's the same
Should be
0x?
this thing, right? Evaluated at those guys.
That'd just be a plus b. No.
Oh, given that
It'd be
t,
a.
okay.
So this is the vector 0, comma a, right?
Which a,
And what's r prime?
t, or a? 0,
Should be 0, comma a, right? So is r prime equal to f evaluated at r? Yep. Check. Cool, that's a flow line. And so the reason I know I'm right about this thing pointing down is that's damn well where a little bit of fish food goes in this thing, right? Otherwise I'd be less confident, right? Because 6th edition, shit, these guys should have their act together by now. Cool? But this is what you guys get for getting the discount textbook. There is a right textbook to teach calculus out of. Stewart. We teach calculus out of the cheap textbook because Stewart is the richest mathematician that's ever lived.